Hello, everyone. Thank you for joining the call again. And Maxim, if you're ready, you can just start with the presentation.
Yes, today I'd like to discuss a number of topics from the point of view of RGB developers, so meaning that it's more technical focused. And all of these questions are related to the development of the first smart contracts based on RGB, covering functionality of fungible assets, what we call RGB20 schema, NFTs, different forms of NFTs, including digital art, identity, naming, and even reputation. Very preliminary work, but I would like to share the results of our research on these topics and the progress that we have so far. Plus, we will have a lot of questions to discuss on the go. I'd like to remind that in RGB, smart contracts have two components. First of all, we have a schema, which defines a family of smart contracts with a certain API. And probably the closest analogy for that would be standards like ERC20 defining API for the fungible token-based Ethereum contracts. But in Ethereum, there is nothing like schema, so it's not obligatory. Here, the schema is in RGB, the schema is required. So it's obligatory that you follow certain API, or you define an API of your smart contract as a custom schema. So when we will be talking about schemas, we will know what it means. And each specific contract starts from Genesis, and Genesis must commit to a certain schema defining actually the functionality of this contract. Again, it can be one of the schemas that we are developing, like RGB20 for fungible tokens or non-fungible schema. We have right now 4 of them, which I will be presenting today, or creating your own custom schema and doing contract with that. So first of all, I would like to start with the implementation progress and updates in the schema and contract-related developments. As a part of RGB core library, we have completed disclosures. It's already gone into the 0.4 release of the node, and disclosures enable us to disclose parts of the information, of the confidential information that some particular contract owner has. And this is used primarily right now, it is used for paying change to itself. So when you pay somebody and you have a change that you're paying to yourself, you'll create a consignment that you set for the remote party. This consignment doesn't have any information about your own change. It's hidden behind the confidential data structures. But to be aware of your own change and to have the choice when you would like to apply that change, when the transaction is mined or not, or before that, you also produce a disclosure internal structure, which is then merged into Stash again by yourself. But the same disclosures can be used for many other purposes, like disclosing information about your ownership, and specifically within the identity and naming schemata, NFT schemata, it's an important part of the story, since with the disclosures you will be disclosing your identity or parts of your identity. Another development is that we are improving and extending general API to work with the state transitions. That helps developing more and more schema and simplifies future development of new schema types by independent developers. For instance, I'm introducing the state unit type, which is basically one step of the contract evolution, linking together the previous state, the new state, single-use seals related to the previous and the new state, and the witness transaction. So it basically takes the information from at least 2 different state transitions and anchor, and links it to that together. So it's not being used in the RGB smart contract validation procedures or internal data storage, but it's just a useful abstraction for the code which will be reading the state of the contract and will create a user interface on top of that, some high-level functionality. We also thinking about and actually coming to a decision that it is quite an important thing of introducing such a concept as data containers and their respective API. We will discuss that later during the call today in more details, and also working on advancements in virtualizing the validation procedure. I will be explaining again at the end of the call what it is, and we will have to make some decision choices in that respect in the foreseeable future. Regarding the RGB 20 contract, which is a fungible asset standard, we are currently developing procedures for the secondary issue and burn and replacements procedures, which are based on epochs. This functionality has been discussed extensively previous summer on our developer calls. I wouldn't be going into these details because it's already part of the story that we decided those days and get to the schema last summer. It's just now we are completing the actual implementation of the API for these procedures. And these parts are very important for us to get such issuers as USD Tether to issue their products on top of RGB, because without secondary issues and burn, you basically can't have USD Tether on RGB. So this is our primary focus. And while we are working on that part, it's it's a good opportunity, reducing future work, to do other stuff which is specific to this smart contract, this schema, and other schemas like NFT schemas, because all of these parts are they're using the shared code, the same code. We can reutilize a lot of code. They are also related to the same topics, like I already mentioned, the data containers, which are useful in spreading the information about asset, especially if it has a secondary issuance and so on. Standardized API to work with the different forms of schema and so on and so forth. Also, we are seeing that for today, we've been distributing the asset information as a form of Genesis data, which contained everything that is required. And this is still true for the assets that do not allow secondary issuance or burn or replacement operation or renomination, which are simple form of the assets. However, that is not enough for assets that can have secondary issues like USD Tether. And I'd like to put an important note for that, because all the demos that we had and all the example code was working with the Genesis. In fact, we are migrating that for working with the consignments, because from now on, the asset information will be distributed in form of consignment, which additionally to Genesis will have all the information about secondary issuance and burn procedures, which will be required for knowing the total supply of the asset in circulation. So the asset information will be published as a consignment data. Genesis blocks still will work, but for assets with a secondary issuance, if you will import just the Genesis data, and there was a secondary issuance happening already, your wallet will say that the total supply is not known. The total circulating supply is not known. You will know the maximum cap of the asset. You will know the primary issues, but you wouldn't know the total circulating supply without this data. So basically, that's why we are moving from the Genesis-based to consignment-based asset information distribution. Another development with the fungible assets is that we have created a subschema. We introduced subschemas last summer, And the reason why we needed subschemas, like we have RGB20 API, that standardized work for wallet developers with all fungible assets, no matter how complex they are, centrally issued fungible assets. So it could be a stable coin with a denomination, burn and replacement procedures, secondary issuance, or it could be a simple token issued once and never being inflated. But still, it is the same schema covering everything. However, while the issuer of the token defines the specific functionality enabled under certain contract, sometimes it is impossible to restrict certain forms of functionality this way. In particular, for issuing the RGB20 assets, we have procedure of burning and procedure of replacement. Replacement is actually where you burn some asset and you create a new form of the same asset, which actually helps you to reduce the size of historical data, which is very important, for instance, for such high velocity assets as USD Tether. But at the same time, these two procedures are very tightly linked. And you can't define a genesis that you allow only asset burn, but you don't allow replacement of the asset. So it's impossible to do during the issuance of the asset. You either allow both of them or just disallow any of them. And that's why here the subschema solve the issue, because with RGB20, we will have a subschema of RGB20, which allows only burn procedure. And if you issue asset under the subschema, you will have the possibility to have burn procedure without the replacement procedure, and notify future users that by this contract, you wouldn't be able to replace the asset. So this is also becoming the part of the RGB20 library. So that's all about RGB20 developments. Maybe short discussion on that topic and questions regarding this part before we will move to other part.
Just a quick question. Can you elaborate a little bit on why might one require the subschema? Like when that will be required for any specific type of assets that they want to issue?
This is required because the replacement procedure, it implies that you must have a higher trust to the issuer. So you should not just trust the issuer about the reserves and fulfillment of the obligations from the issuer, but you also need to trust the issuer that he has burned the asset which is being replaced, not producing the inflation. You are not able to check that fact. You have to trust the issuer. So it's an additional point of trust. And because we understand that many issuers, it should be the case for USDT, for instance, it is required for Tether. But there will be many other issuers who would like to have a burn procedure, but don't want people to think that they will be burning and reissuing asset inflating supply under the schema, because they don't have a level of trust that the required level of trust from the community. So by using subschema, they commit that they will never be replacing assets. And it's technically impossible to do without using subschema, because at Genesis level, you define a single seal which controls both burn procedure and burn and replace procedures. They're not distinguished. You can't distinguish them technically. And that's why if you use the main RGB20 schema, you can't commit of not being reissuing assets ever as an issuer. So if you need that form of commitment, you must use a subschema where the replace procedure is just absent. And this is a subschema of the main schema. So it strictly has the same functionality except certain blocks. So you just remove certain parts. And by committing to that subschema, you make sure that with a client-side validation, the issuer would never be able to inflate supply by cheating with a burn and replacement procedure.
Okay, understood. So they can only be allowed to burn the assets, but not replace it by this schema.
Yes, yes, yes.
Okay.
Other questions? Okay, I will proceed further to the NFT-related topics. And I would like to start with the first schema. We will have a set of schemas related to NFTs. And the most common one and most interesting for the community today is probably digital art and virtual items, which is defined by the single schema, which we call RGB 22. It will also have a main schema and a sub-schema, like RGB20. The difference between them will be the fact that with a sub-schema, with the main schema, you will have an engraving procedure. The procedure where you can add a custom data. The current owner can add his own custom data to the NFT token, like adding some engraving on top of the art, writing something on top of that. And to prohibit that procedure, if the issuer of NFT token would like to have the NFT token without engraving procedure, he will have to use the subschema for that, which prohibits engraving. We've been discussing the engravings that are required and what are the potential use cases for them on the call that we had for NFT assets last October or November. So today we are not going to discuss the NFT schema. It's more or less standardized. The only development that happened since that time since the last discussion is that I have simplified the NFT schema. And it was possible because the introduction of the data containers. So basically, we solved two problems. The first problem was the complexity of the schema when we were trying to create individual data records for each of the NFT tokens and transfer them in parallel. And the RGB client validated data, they are not very much suited for non-validated data, which is NFT data. And the second problem was the fact that with the RGB, again, we are trying to keep this client validated data as small as possible, and there is a limit of 64 kilobytes for each piece of the data, and many NFT-related things are not fitting into that limit, like media files, audio, video, even GIFs, animated GIFs probably wouldn't fit 64 kilobytes. And that was quite a big problem. So we found these data containers, which we will be discussing again after this very important addition, which solve a lot of different pitfalls with RGB. And the idea with the data containers that additionally to client-validated smart contract data with RGB, we will have arbitrary blobs, big amounts of data, which can be attached to the smart contracts, but which are not validated. So we are not restricted by their size. It's an external resources distributed using the Bifrost and Lightning network, which can be kept locally or in decentralized way with a different storage protocols like Bifrost and Storm, for instance, paid with the Satoshis in trustless way. But still, you are able to work with them without you are able to work with the RGB smart contracts without the need of downloading these gigabytes potentially of the data. It's pretty much the same like distinction created in Bitcoin with SegWit, where you have a witness data structure, which is external to the transaction itself. It's not exactly the same because witness is used in validation while the data containers are not. But let's discuss that in more details once we get to that section of the presentation. So these are two main developments that happened to NFTs. And with that, we actually were able to create a schema that has a certain advantages over other NFT technology listed here. So first of all, a lot of improvements to data storage. We don't store any NFT data in blockchain, but at the same time, we do not need IPFS We don't need a trusted website that will store the data, or we don't need a special data management solution dedicated for NFTs, which is, I think, one of the main industry problems with NFT today. The second thing that we will discuss on the next slides is embedded digital right management type of encryption and ownership management. Let's discuss that next slide. Engraving procedure, absent in the other NFT solutions. Again, there is no place for them to store those engravings. Infrastructure for backups utilizing Lightning Network, and much more ways to monetize the content of the NFT, because you have ability not to sell not the NFT ownership, but the access and use rights, and do that multiple times. So I will explain that on this slide. So how we are going to make digital right management with NFT anarchic and trustless, let's say it that way. First of all, because of use of these data containers external to the RGB smart contract data, we are able to encrypt those containers such that while you will be still distributing them over the network, like Lightning Network and Bifrost, they will be distributed in an encrypted form, and only the owner of the NFT token or those parties whom he sell the usage right will be able to decrypt and access the content of the NFT token. So basically it is a digital right management system, but it is very different to the DRM systems used in the industry today. First of all, because it doesn't try to enforce the rules by introducing forms of protection which are beneficiary actually to intermediaries. We had a in-depth discussion on this topic in the RGB chat over the Telegram, and it's been pinpointed at the head of the chat. So because today is developers calls, I wouldn't be digging into the details of that, but I will be happy to answer the questions if you will have ones after the next slide. But generally, with this type of DRM system, we differentiate the rights of ownership and the rights of use. So usage rights are controlled by access to the encryption key. So if you have the encryption key, you can basically read the content, and you don't need an on-chain transaction to sell the usage rights. So this is very scalable procedure where you can sell the usage right of certain NFT token as an owner without the need of on-chain or Lightning transaction. At the same time, you are also able to transfer the ownership, which is different from usage rights, and that is done with an on-chain transaction, or that can be done within the scope of the Lightning Network only inside a single channel, which can be potentially in the future multi-peer channel, but you can't, of course, sell the ownership right with a multi-hop payment, with a multi-hop Lightning Network transfer, because it's impossible for any kind of NFT to be used. The NFT is a singular in the university. You by definition don't have a liquidity. So that's our two rights which we distinguish, and again, that's the point where NFTs using RGB are very different from other NFTs existing today. And we're basically, I would say that literally we destroy the copyright, the right to copy, and replace it with three different rights. Authorship, it's still there, as in the real world and any other scenarios. And also there is a distinction between the right to use and the ownership right, because technically you can't control who has the right to copy. It's impossible. It produces a lot of malformed practices, the desire and attempts to control the right of the copy for digital mediums. So we can't control who is copying the asset, and in the trustless world, we are just not trying to protect the copyright. What we are defining and be able to protect, first of all, we define and able to enforce the ownership right, thankful for single-use seal system used by RGB, and we are able to provide a usage right, but we are not able to enforce it. Meaning that, of course, if somebody publishes the decryption key, then usage right can be obtained by anybody forever, because it's out there. So we can't enforce that the usage right will be sold only by the current owner. It can be sold by the previous owners and so on and so forth. But there are economical mechanisms into which we believe, and we had discussed them in the RGB Telegram chat, that actually those people who are not able to pay for certain media content, like a song or a painting, the DRM system enforcing the usage right wouldn't be able to force them to pay, because they don't have money. They don't have money to pay for that. So they will be either not using or using for free. And you can't solve that problem without making people more rich. And we are not trying to solve and address that problem here. But instead, for those who are able to pay for the content, of course, there will be some proportion of people who wouldn't be paying that and just stealing the content. But again, the most of people paying money, they would like to pay to the owner of the content, because they would like, still, like with any capitalistic environment, you still have a desire to support the producer of the content or the current owner of the content. So in most of the cases, think that this system will work. And the most important part that it does, it reduces the need in the intermediary, which today accumulates the vast majority of the profits from the industry, not the content producers, and which are making the prices for the media content so high that it's not plausible to pay that amount of money, actually driving the pirate and the industry. So I think with a proper economical establishment of the digital right management system, as I described here, it will be possible to have much less piracy without strict enforcement and without the copyright. So that's a hypothesis we will try to check with the practice. So there is a number of questions to discuss regarding the NFTs, but before discussing those questions, let me check with all participants. Maybe you have some other questions. Start with BAM and then move to these ones.
I have a quick question. I think one of the problems, so okay, are we solving the problem of free riding or are we not, in theory?
Well, problem of free riding has a lot of different forms.
Yes.
So
yes.
with specific form, like, would it be possible for people to do a pirate thing, like the Pirate Bay of RGB NFTs? Yes, it will be possible. So if the current owners or the users of the content who paid for that will be willing to publish the same content for free using the pirate system, well, they will be able to do that, of course. Would they have an incentive of doing that? Well, I don't see any incentive of them doing that. But of course, somebody will find some. So I think we are not enforcing the solution of the problem. We are creating the system where it's not incentivized. Because again, by today, the pirate industry is well developed for songs and so on. Because there is actually a problem. Two problems. First of all, the prices are too high, and because of the intermediaries, and people do not believe that they have to pay intermediaries, not the content creators, for listening music, and that they are not own or control the music. They are using just a subscription or something. So it's very malformed practice which incentivizes the pirate industry. If you change the practice, the pirate industry would lose most of its incentivization. So while we are not prohibiting it or trying to enforce that it's not there, we believe that it will be significantly reduced, and the content creators will be able to earn much more resources than with today's system, which is the end goal.
Got it.
I have a question. I think that the ownership rights and the user right is a very, very good implementation. But I have this question around, can like a specific asset have both user rights and ownership rights? So in the case that like an asset was issued, like let's say music, right? And then someone else owns it now. So when users use that, right? Will the whole thing still go to the person who owns it, or will it go to the creator, the author rights, with the author rights?
Well, the idea is that the owner, so the person who has ownership rights, decides who can use it and under which conditions. However, in practice, of course, all previous owners and content creator will be able also to provide others with ability to use, like they can expose the decryption key and nobody can prevent them. But this will be a pirate industry because they will be doing that without being able to confirm that they have the right to do that. And we estimate, because this confirmation of the ownership right will be a part of the content you are buying, so you will be able to check that you are buying from the content owner or you're buying from non-content owner. So you will clearly know that it's a pirate thing or not pirate thing. Probably pirate thing can be cheaper, of course, but the decision will be left on the end consumer, whom to trust, not to trust, but whom to support with his own funds. And he will have a clear picture that this content, and this is a usage right coming from the content owner, and this is a pirated right coming from nobody knows who. I don't know, does it answers your question?
Yeah, I think it does. I'm just wondering if it's going to be like the subschemas that will be used in defining also how because if the problem here is that if someone goes to go own the assets, right, and he owns it, and then he might believe that he's owning it because he's going to get some percentage of the user rights so that other people who were using it really could use it. Because now on NFTs, if you own an NFT, you totally own the whole asset, right? And so that is why there were like people are talking about like royalties and stuff. So if there is a way to have like a mechanism where the new owner could still benefit from owning the asset while the author still also benefits from creating the asset, that would be a very great use case.
Well, if the creator of the asset would like to benefit from creating the asset, he shouldn't pass the ownership right on that asset and just sell the usage right. And by that, he is even more protected because there are no past owners who can do a piracy. There are only the users who can just provide that content for free, but it's slower risk. So if you'd like to benefit from your content, don't sell it as an NFT, distribute as an NFT for money. But if you sell the ownership right, you sold the ownership right, and you have no right to earn money from that content unless you established some certain other form of contract with the person whom you sold the ownership, that certain percentage of that ownership goes to you. But in fact, you will create a multi-sig with two of you, and you will sell the ownership to the multi-sig, which you also control, sharing the revenue with somebody else. So this can be all done within the scope of existing Bitcoin technical functionality.
Thank you.
Today, the content producers are enforced to sell the copyright because otherwise they don't have a distribution network. And that's why the whole label and distribution industry exists, because it's a monopoly, in fact, which forces content creators to sell the copyright and not being able to earn money from that content in the future. Why? Because otherwise there will be no way for them to provide this content to the end users. With the Lightning Network, Bifrost, and the infrastructure we have in RGB, it's not the problem that you can't provide the content to the end users. And there is no need in selling ownership right. Unless, for instance, somebody decides, okay, I will sell it for 2 million and will not bother with the distributions. Somebody else will be doing that. But it's a free choice. It's not enforced by existing monopoly. So we expect much more reasonable and fair market. Other questions?
There is a question from the chat. So the author can always make the content available for free after selling the ownership via pirate website, for example.
Yes.
Mm-hmm.
But he wouldn't be able to prove that he is an author. So it will be like, for those who will be buying it, it will be clear that this is an unknown pirate thing. So he will have a choice to get it for free or pay very small amount of money or buy it from the owner. And of course, people who don't have money, they will always choose the free stuff. But if you will prohibit you may try to prohibit the pirate market, but the fact is, and reality is that first, you can't prohibit it. Technically, there is no way of doing that, so it will still exist. And the second, and it will just, your attempts to prohibit it will create a monopoly and reduce the income of the content creators at the end of the result. So no way, no reason of trying to do that. And the second, that people who are who don't have money to pay for the content, they wouldn't pay for the contract anyway. They don't have money. So you can't earn money from them. The only thing that you can do is just give ability for those who would like to pay and support the producer to do that without paying intermediary. And that's the exact problem that we are solving here.
Thank you for your answer.
Okay, so the questions, technical questions I'd like to discuss here. First of all, how to define the type of the content distributed with these data containers. Instead of inventing new standard, which is a normal way that we do, we have here, I propose very unusual solution is to reuse existing standard, which is well known as a MIME content types, or today it is being renamed into media content types. The only drawback of that, there are two drawbacks. The first of all, it's a centralized government-controlled standard. So today it is controlled by IANA, which is very well-known US government-controlled agency, the same agency who provides IP addresses and everything like that. So they can, but again, it's about content type. It's not about content. So they can't censor certain forms of content. But still, if you would like to add additional types of content, you will have to go to them and get the registration or something. So for that reason, but there are ways you can do a vendor-specific content and so on and so forth. So it's not a big problem here, I believe. But still, what I would like to propose is to have MIME standards defined as default, but also add additional type of mini content, which will be defined with a very clean public use options, starting, for instance, from LNPBP or something like that, the root type of the content, that anybody who are not unable to get permission for the newly developed content type from the US government, they will be able to follow this open standard instead. But still, all the other existing standards applies from the MIME type. So that's the first proposals. And if you will have any objections or think that it's still unsafe to use MIME or any other thoughts, you're welcome to share them right now or write in GitHub discussion under LNPBP. Any comments on that question?
Probably not on the current one, but overall we have two questions more. First question is, can you spawn a set of NFTs with one transaction and hence save some transaction money? And the second question is, well, yeah, it's part of the similar question, same question. The transaction fee set a lower limit for how low value NFTs it makes sense to sell. The transaction, huh.
Well, again, you're selling not usage right. With it, you need transaction only for selling ownership right. So you can, the transaction fee doesn't define for how much you can sell the usage of the content. But yes, it defines the ownership. But it is possible to, we already discussed that plenty of times, and we made even public tweets. You can bind 65,000 of different NFTs into each output of a single transaction, NFT contracts under which you may have up to 65,000 of NFTs by the same publisher. So basically you can have up to 2 billions into each transaction output. And if you will have like 10 outputs, you can do plenty of transactions at the same time. So you are not limited by the scalability and the fee. Of course, in the most of cases, you wouldn't be able to pack such a lot of transactions. But if you need to, you can design a special coin join type thing that will save people fees. It's a sort of proper the key rollups, probably, if you can compare that for the Ethereum bullshit they're doing. So the second question, which form of encryption to use with encrypting the content? We have options of using simple standard encryption, central encryption, and using you store basically the password in the client validated data. You can make it confidential with the normal RGB procedures, and of course all of the future owners of the content will have access to that decryption key, which is a simple start. But maybe we will need something more like asymmetric encryption with changing the encryption key with each ownership transfer, and even being able to use different encryption keys when you are selling the content. So you will be able to track if the key will be published and the contract and the content will be available on some pirate website. You will be able to see who of your customers or the previous owners actually did that. So it's a sort of DRM tagging style thing, which is more technically complex, but it's also doable. The question, would it influence the game theoretical model of the NFT economy in a good way or bad way? That's another question to discuss. Again, it's not the questions to make decision today. It's more like for the next couple of weeks to see what is the best way of implementation of NFTs. And if anybody has opinion right now, you're welcome to share it.
We will eventually post these as discussions on the standards repository, right? I think it can be helpful.
Yes, if you can do that, probably.
Yeah, I will do it.
Yeah.
Good. We have a question, by the way. Why do you have to define the media type in protocol and not leave that option to the creator of the NFT?
Well, because if we will not define it in the protocol, the software developers wouldn't have a standard way of supporting different content types, and we will end up that different software will be using different things, and like a lot of headache for the industry. So basically, it will be defined in a portion which is not a part of RGB or RGB schema at all by itself. It will be defined by the portion that defines the encoding and storage of the data containers, which are not part of the client validated data. So, but because RGB contract will commit to the hash of the data from the data container, this hash will include the media type, of course, which will be the part of the container, and it has to be well-defined format of definition of the media type. So 2 reasons. First of all, it's still, while it's still outside of the client-side validation part of the protocol, it should be part of the protocol because the way client-side validation works here. And the second, just to make sure that content creators do not have a headache with a lot of software using different standards, and they have to find a way how to do that. And then final question is there any other requirements for NFTs which we potentially miss? So if you have any thoughts on that, you are also welcome to share. Shall we proceed to the next topic, or we are fine in this stage?
Well, for now, we don't have any questions. So guys, if you have any questions, just drop them in the chat. We have 45 minutes of recording. How many slides do you have? Maybe it would be better.
Yeah, see that there are too many of them, and we are just on the 10th slide. I also think that the next big part of the presentation is identity, naming, and reputation, which is also an NFT-related topic, and it's most of the presentation covering this thing. And there is very important discussion, but I'd like to have Giacomo on this discussion, and certainly it wouldn't fit the timeline of this call. So probably the next call will be more a community call. This is a bit technical, but I still think it can be discussed on that call. So for the next call, I plan the demo of the issuance, secondary issuance of the fungible assets burn procedure, and maybe demo of issuing the NFT tokens on RGB. And I think we will have time. It wouldn't be a long demo. We will have a time for discussing this part. So I will move it, and then the last thing. So we have like 1, 2, 3. Like with the content 1, 2, 3, 4, 5, 6, 7, 8 slides to discuss for this call.
Should I relaunch the video recording?
How much time do we have?
10 minutes.
Yeah, let's go for now, and then we will relaunch it after that. So at least we can discuss the data containers. I already introduced this concept of data containers, which are keeping large size, big records of non-client side validated data. The use cases for these data containers are the following. First of all, NFT media resources. So we will be storing all this content coming with NFT in these containers. Each container will have identifier, which will be a hash of the contained data, and the RGB contract of different form, not on the NFT, any one of them that needs these external data containers, will use this hash as a part of the state within their own rights. So basically, when you define the Bitcoin transaction owning this content, within RGB data, you will provide the hash of the data. And this is at the same time the identifier and the way you can check the integrity of the content that you received, because it's a hash of the content data. And it's pretty much the same like is used in BitTorrent and other protocols. Also, this hash will be created not from the whole data, but the data will be split in chunks, aggregated into a Merkle tree. Again, pretty much the same like it works with a BitTorrent. Another important step that because you can have a confidential state in RGB contract, you can make this ID hidden or confidential, because at the end of the result, you have the same procedure like you hide the rest of the state. So this identifier will be hidden until you are the owner of the UTXO. So those who will see the history of the contract, they wouldn't be able to see which content was owned by this person. Additionally to that identifier, there will be an encrypted form of the content, and of course, for encrypted form of the content, you will have another identifier, another Merkleized hash of the data, and that will be specific to the encryption key. Encryption key will be kept also as a part of the state data, and again, it will be able to become confidential. And because of this confidential encryption key, we actually add sufficient entropy such that when you hash the identifier of the content together with the encryption key, you wouldn't be able to build a rainbow analysis table. So those who will be storing the content, like Lightning nodes, Bifrost servers, and so on, they will not know which content they are storing at all. And they will be, when they will be asked for the content by ID from the ID, they wouldn't be also able to infer which form of the content that is. So these data containers are quite confidential thing as well as everything else in the RGB. Additionally, for storing NFT media resources, they can be useful for storing a large size Ricardian or other forms of legal contracts related for fungible tokens, for different forms of asset media information, which we've been discussing, like issuers of the assets may like wallet to provide wallet developers icons, custom design things related to this specific asset, and RGB doesn't allow to do that, but it will be possible to do and distribute that part of that content with these data containers, which solves that problem of how to distribute that asset meta information created by the issuer. Additionally, we will move the proofs about burn and replace procedures, because the current fungible asset contract, we reserved the place to store in the future some zero knowledge proofs about the amounts of the assets being burned, not amounts, but proving that we haven't created inflation with the burn and replace procedure. Not today, but when we will have a developed protocol for that in the future. But instead of storing that inside the contract, we will be providing the data containers to store that content, so everybody who will be using token, they are not forced to download all that large size zero knowledge proofs. Storm storage data, so we plan to use that in Storm data storage, decentralized data storage protocol, and in Bifrost consignment storage. So we will use the same mechanism in the Bifrost network to store third-party consignments and encrypt them, again with the data containers. And maybe you already heard that long-term, we have the protocol called Prometheus for machine learning and high-load computing, and the models, different forms of data models, and the data actually, and the ownership of the data. Again, it's a form of NFT token within the RGB system, and this data will be stored in the same form of the containers, also providing a layer of security of the model data and the big data that are used in machine learning. So that's the use cases. And there are very simple rules of using them. Is first of all, these containers are not client-side validated. So they are not accessible to schema or simplicity scripts inside RGB smart contract. So it's just external data. The only validation is that the software makes sure that ID matches the content of the container. It's a Bitcoin witness type of extension, not exactly because witnesses are part of the validation, but at least in the part that you have an option of not downloading this large size content or not storing it locally, and you do not need to download it for the history and validating the history. So that's all for containers. We have still like 4 minutes of the recording, so maybe there are some questions, and after that we will launch the video.
Can I ask what can be approximate sizes of the data containers that you need to store?
Any. Literally, we will put no probably limitation on the size. It will be split in blocks and download by blocks, pretty much like in BitTorrent protocol. And again, it's your choice of downloading this content or not downloading this content.
Got it, thank you.
And probably even because we don't have a lot of questions, even without relaunching the video recording, I will cover the last part, which is introduction to Bifrost. There will be a dedicated call about Bifrost protocol design. It's a protocol operating as a part of Lightning Network and used for storing RGB-related, distributing and storing RGB-related data, including the data containers, which we just discussed. So it's basically an extension of existing Lightning Network P2P message system with a new message types. Again, it is specific only for RGB. it is not the same as other extensions to P2P messages in Lightning Network, which allows you transferring the RGB assets. It's not part of the Bifrost. So Bifrost is only part of the RGB that is related to data storage. And it's not the same as Storm, which is non-RGB related and generic storage. Right now, it's not even operating on Lightning as the protocol is designed, but we will change that in the future. And the Bifrost protocol will be an important part of RGB payments, RGB20 payments, when receiver is offline. So you will use Bifrost protocol to store the large consignments on provider server. So when the mobile gets online back, it will be able to download the consignment layer. So the payment becomes non-interactive, RGB payments. The same for NFT media distribution, identity and decentralized naming system, which I hadn't time to cover this call, but I will be covering the next one. And they will be also an important part of the DEX that we have plans to build at the end of the year, providing the asset information for DEX participants. Bifrost solves these tasks. It solves the task of passing RGB consignments for different forms of transfers, spreading RGB genesis or information about secondary issuer and supply of the asset, asset meta information by the issuers, like signature of the issuer, signing the asset, making sure that linking it, the asset to the identity of the issuer, and different forms of media resources like custom icons or wallets, and storage of data containers, including storage of the encrypted consignments for the third parties. The early draft of the protocol, very early draft, is available on this link. And in a few calls, we will have in-depth discussion of the protocol and its design when we will be working on the Lightning Network protocol part. So I think we can relaunch the video, have the questions, and then the final few slides.